If you're building AI native apps right now, you've almost certainly tossed a CLAUDE.md file into your repo. I mean, it's a no-brainer, right? It is incredibly powerful for steering those AI coding assistants to match your exact style and conventions. But, well, here's a fascinating twist we're going to dive into today. While it's a totally fantastic tool for setting that initial context, it inevitably breaks down when you try to use it for architectural governance at scale. So in this explainer, we're going to figure out exactly why that structural breakdown happens, and more importantly, how the industry's actually solving it.
Okay, let's dive right into our roadmap for this explainer. First, we'll look at the rise of CLAUDE.md, then hitting the instruction ceiling, followed by the 5 failure modes. After that, we'll cover the memory misdiagnosis, and finally, the new governance stack.
All right, part 1, the rise of CLAUDE.md.
You know, we can actually trace the exact chronological bloat of this file, and it's something I'm sure a lot of you have experienced firsthand. In month 1, it's a total frictionless productivity asset. You're a solo developer, you drop maybe 50 to 150 lines in the repo root, just some basic coding conventions, maybe some testing expectations, easy. But then, month 6 rolls around, complexity strikes. We're suddenly adding edge cases, deployment workflows, directory rules, and boom, it balloons to 600 lines. And by month 12, it is total governance overload. We're talking well over 1,000 lines of stale decisions, conflicting instructions, and weird team-specific exceptions. What started as a genuinely helpful style guide has literally transformed into an unmaintainable monster.
Which brings us to part 2, hitting the instruction ceiling.
Now, what's really interesting about this slide is a massive distinction we have to make. The presence of instructions is not equivalent to enforcement, right? A text document can flawlessly describe a rule. Like, it can explicitly state, hey, use the repository pattern for all data access. But fundamentally, a plain text file cannot prevent the model from bypassing that pattern if the task signal is strong enough. The team basically makes this mistake where they shift from maintaining instructions to attempting to maintain a whole governance system. The rule is there on paper, sure, but the actual enforcement infrastructure, it's entirely missing.
Okay, moving on to section 3, the 5 failure modes.
We need to be clear about something. These 5 structural breakdowns, you can't fix them just by, cleaning up your document or doing some clever prompt engineering. It goes deeper. First up is context accretion. Basically, rules just accumulate without any prioritization, so your absolute most critical architectural boundaries end up getting buried under a mountain of outdated footnotes. Second, there is no deterministic enforcement. If a task is super urgent, the model might read your rule, but it's going to violate it anyway just to get the job done. Third, no decision providence. Institutional knowledge just decays. You completely lose the history of why a rule exists or when it got superseded. Fourth, poor scope resolution. Think about it, a global organizational rule and some tiny niche team exception look exactly identical in a flat file. And finally, number 5, agent drift. In a complex, multi-step workflow, an autonomous agent might start out perfectly aligned, but by step 12, it is completely drifted away from those instructions it read back in step 1.
That leads us right into part 4. The memory misdiagnosis.
And this brilliantly illustrates how the industry is widely, and I mean widely, misunderstanding these failures. Teams look at this and often assume the model simply has a memory problem. They think, oh, the context is too long. The AI just forgot the rule. We just need to build some complex RAG pipelines or use semantic search to fix it. But the actual problem? It's an enforcement problem. The rule was entirely accessible. The model saw it, but it bypassed it anyway because there was no hard constraint. You absolutely cannot rely on probabilistic compliance where a rule only usually works when you're trying to protect strict security requirements or hard service boundaries. That is just a recipe for disaster.
Which finally brings us to section 5, the new governance stack.
Enter the governance layer. This right here is a complete paradigm shift. A governance layer is a deterministic enforcement layer that operates on structured, typed decision records. This introduces tools like MnemiHQ, which is an open-source architectural compiler. Instead of just kind of suggesting rules inside a prompt's context window, this layer sits above the context window. It actually resolves precedents and catches violations at the hook level. It is literally stopping bad code in its tracks before it ever even reaches your pull request. Now, to actually achieve this in practice, we need infrastructure that goes way, way beyond a simple text file. We need scoped governance, so rules apply exactly where they belong, whether that's at the global, service, or just the directory level. When those rules inevitably conflict, we need precedence resolution to handle it deterministically. We also need strict enforcement checks to actively block those violations right at the hook level. And of course, we need decision provenance to maintain the rationale and history of absolutely every constraint through ADR tracing.
So the absolutely crucial takeaway here is that CLAUDE.md is not obsolete. Not at all. Actually, these two layers are perfect complements. CLAUDE.md lives in the context layer. It's an advisory text file that is absolutely perfect for behavioral steering. Setting your style, naming conventions, getting the session prepped. But Memone HQ, that lives in the governance layer. It relies on typed decision records for strict hook-level blocking to actively enforce your architectural constraints. So basically, CLAUDE.md keeps your context aligned, while Memone keeps your architecture enforced. They work together.
I want to leave you with a final provocative thought today. As code generation scales exponentially faster than governance, and as AI agent workflows become longer-lived and fully autonomous, is your architectural integrity actually protected by deterministic enforcement? Or are you just relying on a really, really long text file? Because relying on instruction surfaces alone is pretty much a guaranteed recipe for system collapse. It's time to start building the governance infrastructure that this kind of scale actually demands. Thanks for exploring this with me today. Keep learning, keep building, and I will see you in the next explainer.